Now you can see the head is on the 0, and I'm only going to take a 1 revolution dial, which will make my hole 0.050 bigger in diameter. So I'll go ahead and I'll put my Allen in, rotate it 1 revolution, which is back to 0, and after this pass, I'm predicting that my hole should measure about 0.886, and I'm going to check it and see where I am. Now, if it's a little bit off, that'll have something to do with the tool pressure difference between my first pass, which was barely cutting metal, and my second pass, which is removing 50 thousandths out of the bore, 0.050. Now I just completed my second pass, and I'm predicting that I'm going to have a hole size of approximately 0.886, like we discussed. So I'll put the tool in the hole, and right now I know I'm at 0.850, and if I take another spin, I'm at 0.875, 5 more thousandths is 0.880, 885, 886, 87. So I'm going to call that about 0.887 and a half. And it's important that I take the reading while it's in the hole. I don't want to remove the tool and then take the first, have that be the first time I look at what marking I'm on, because like I probably just did right there is I can inadvertently bump my measurements. So that's why it's important to hold the tool in a manner that I can take a reading while it's still on the part itself. So this is my last pass. I ended up with a diameter of 0.887, and I'm going to 1 inch. I have approximately 0.112 to go, and now I'm going to divide that up and take that in 3 passes. Now I'm not going to do 3 identical passes because, again, I like to stay on whole numbers, meaning 0, 5s, and 10s. So I'm going to take a 40, and then I'm going to take, well, whatever is necessary to end up at 1 inch. So what I'm doing is I'm going to have a consistent chip load for my last 3 passes. So I'm on the 0, that's 10, 20, 30, and then 40. So now I'll take that pass. All right, let's measure and see where we end up after that pass. Now I was at 887 and I took 0.04, so I'm expecting to be at about 0.927, 926. We'll see. Right now I'm at 0.9, and I always like to go ahead and make life easy and identify where I am before I put it in the hole, especially if I have limited view like I do right now. And if I spin it, I'm at 915, 920, 925. Start to wiggle it around, find the widest point, or make sure I'm getting the whole diameter measured correctly. And I'm measuring about 926 and a half. Yeah, so 926 and a half, so almost 927, and that's where I thought I would be. So I was at 927, and I'm gonna go ahead and take another 40 thousandths, which should put me at about 0.967. So Here I go, I'm on 40, and I'm gonna move 10, 20, 30. I moved 40 divisions. Now I know I'm on the 30 marking, but that's just the marking. I only moved 40 divisions. And again, after this cut, I should be at about 0.967. All right, so here I am. I just took another pass. I think I should be about 0.967. Right now I'm starting with my micrometer set at 950. So then I know that when I put it in the hole and I give it a rotation, I was at 950, so I'm at 955, 960, 965, 960, almost 967. So that means that things are going well, because every pass I've taken, I've ended up within a half a thousandths of where I thought I should be. And I was just looking at my print, and I can actually be 1.000 to 1.002. So I have 2 thousandths worth of tolerance. And I'm going to go ahead and use that 2 thousandths of tolerance to my advantage. So I'm going to aim for 1.001, which would mean that I would make a 0.034 adjustment right now. So 34 division marks. I'm on the 30th division mark. So I'm going to rotate it. 10, 20, 30, and then be very careful. 1, 2, 3, 4 more. Now, it's important that I was very careful like that, because if I went past it by 2 thousandths, I've really made a bad mistake at that point, because I have to back the tool away, and at which point I've lost my consistency that I've been working so hard to maintain. So be very cautious when you're taking your final couple passes. Pay attention, be patient. Now, you notice I just stopped the boring head in the bottom of the hole, or actually it's through the bottom of the hole. And what I'm going to do is I'm actually going to move the table this way, away from the tip of the cutting tool, and I'm going to bring it out so it doesn't rub the board. Now, what you haven't been able to see through the camera is every time I rapid or pull the bar out while it's spinning, it is leaving circular drag marks. So if I actually move the table away, now when I come up out of the hole, there was a large clearance gap, so it didn't drag coming out, because I would never want to drag a tool out of a board. And then I'll go ahead and immediately position my table back where it was on using the readout, back to my 0.000. Because if I had to go in for another boring pass, well, if I'm off 200 thousandths, I could break my bar, and then I could also definitely ruin my part. But we can move away, but we have to be paying close attention, and that's why we're not visiting with our friends or our classmates. We're focusing on the part that we're machining. Okay, so now we're going to see if all of our hard work has paid off, and we're taking our final measurement. Now, I was aiming for 1.001. Now here I am, I'm at 1 inch, and I still have a little bit of wiggle, so I'm going to wiggle around. I'm using the ratchet, and I got it to jump up to 1.001 in about 8/10. And I'm in the tolerance zone, and I'm going to call that a big success.